The F-35A Lightning II is more than just a fifth-generation fighter jet. It is a marvel of engineering that symbolizes American air superiority in the modern age. Designed to combine stealth, speed, and unmatched intelligence capabilities, it represents the United States' relentless pursuit of technological excellence. Built during a period when global air dominance was paramount, the F-35A has evolved into a cornerstone of modern warfare, a machine that seamlessly integrates human skill with artificial intelligence and precision weaponry. But what makes it so revolutionary, and how did it rise from decades of experimentation to become one of the most advanced aircraft ever to take flight? From Cold War dreams to the birth of a legend, the roots of the F-35 trace back to the late 20th century when the United States sought to consolidate multiple aircraft programs under one initiative. During the 1980s, the Advanced Short Takeoff Vertical Landing Project aimed to replace the Marine Corps' Harrier jump jet with something faster and stealthier. Lockheed Martin's Skunk Works division led the effort, experimenting with an innovative lift fan system that allowed vertical takeoff and landing while maintaining supersonic capabilities. By 1993, this project evolved into the Common Affordable Lightweight Fighter program, bringing major players like Lockheed, McDonnell Douglas, and Boeing together in a rare moment of collaboration. However, the collapse of the Soviet Union in 1991 reshaped global defense priorities. With defense budgets shrinking, several ambitious programs, including the Air Force's multirole fighter and the Navy's AFX projects, were canceled. Out of this turmoil emerged the Joint Advanced Strike Technology program, which focused on developing cutting-edge technologies that could one day serve as the backbone of a new family of fighters. By 1995, Common Affordable Lightweight Fighter and Joint Advanced Strike Technology merged to form what became known as the Joint Strike Fighter program, the foundation of the modern F-35. International collaboration was a defining feature from the start. The United Kingdom joined early as a key partner, followed by Italy, the Netherlands, and Canada. Their participation ensured not only shared costs, but also shared technology and access to the next generation of aerial warfare. The X-Planes, a contest for supremacy. In 1997, Boeing and Lockheed Martin were selected to design and build competing prototypes. Boeing introduced the X-32, while Lockheed presented the X-35. Both prototypes were tested under extreme conditions to prove their worth. The X-35's superior performance quickly became apparent. It could transition from hovering to supersonic flight with remarkable stability. This innovation was thanks to its unique shaft-driven lift fan system, an idea that transformed vertical flight into a practical reality. 3 versions were created to meet the needs of different military branches: a conventional takeoff variant for the Air Force, a short takeoff variant for the Navy, and a vertical takeoff variant for the Army takeoff/vertical landing version for the Marines, and a carrier-based model for the Navy. The first successful flight of the X-35A occurred on October 24, 2000. Following extensive testing, Lockheed Martin's design triumphed over Boeing's, and in 2001, it was officially selected for full development. Pratt & Whitney was chosen to produce the F-135 engine, a powerhouse that would become central to the jet's legendary performance. The F-35, a supercomputer with wings. What truly sets the F-35 apart is not just its stealth or speed, but its brain. Often described as a supercomputer with wings, the F-35 integrates an extraordinary range of sensors and computing systems that enable pilots to dominate any battlefield. At its core lies an advanced active electronically scanned array radar capable of tracking and engaging multiple targets in the air or on the ground simultaneously. Equally impressive is its distributed aperture system, which uses 6 infrared cameras mounted around the aircraft to create a 360-degree real-time view. Pilots can see through their aircraft using helmet displays that project images directly onto their visors. This revolutionary technology provides unparalleled situational awareness and allows pilots to detect threats, navigate in total darkness, and even engage targets they cannot physically see. Beneath the aircraft's nose sits the electro-optical targeting system, which combines infrared sensors and laser targeting to identify and track enemy assets with pinpoint accuracy. The Invisible Jet, mastering the art of stealth. Stealth is the heart of the F-35's design. Every angle, panel, and surface has been crafted to minimize radar detection. Its radar cross-section is said to be smaller than a golf ball, achieved through radar-absorbent materials, precise surface alignment, and a diverterless supersonic inlet that eliminates traditional radar-reflecting components. Unlike older stealth aircraft, the F-35's surface coating is durable and easier to maintain, ensuring consistent low visibility visibility without the extensive upkeep that plagued earlier stealth jets like the F-117. This design allows the F-35 to infiltrate contested airspace undetected, strike its targets, and escape before enemies even realize it was there. Although low-frequency radars can sometimes detect stealth aircraft, they lack the precision to lock on, giving the F-35 a decisive advantage. Inside the cockpit, innovation meets intuition. The F-35's cockpit is a masterclass in human-machine integration. Instead of traditional dials and switches, pilots operate through a panoramic touchscreen display that combines navigation, targeting, and flight information into one interface. The absence of a conventional heads-up display is intentional. Every piece of critical data is projected onto the pilot's helmet visor through the helmet-mounted display system. This helmet, valued at around $400,000, provides infrared vision, night vision, and even allows the pilot to look through the aircraft using the DAS system. It's an engineering masterpiece that transforms the pilot into part of the aircraft itself. The system went through years of refinement to eliminate vibration and alignment issues with the Gen 3 helmet introduced in 2016, achieving a flawless combination of comfort and precision. Supporting this interface is the aircraft's hands-on throttle and stick control system, an onboard oxygen generation system, and the Martin Baker ejection seat, ensuring both efficiency and safety in the most demanding conditions. The F-135 engine and weaponry. At the heart of the F-35A is the Pratt & Whitney F-135 engine, one of the most powerful jet engines ever created. It produces up to 43,000 pounds of thrust in afterburner mode, giving the aircraft more thrust than its total weight. This allows it to perform breathtaking vertical climbs, sudden maneuvers, and high-speed engagements that would overwhelm most jets. In terms of weaponry, the F-35A carries an internal GAU 22A 25mm cannon capable of firing 181 rounds. With its burst limiter, the pilot can choose the number of rounds per trigger pull, offering precise control in combat situations. Inside its concealed bomb bay, the jet can carry a variety of precision-guided munitions ranging from 250 to 2,000 pounds. Depending on the mission, it can engage up to 8 separate targets at once within a range of 70 miles. When stealth is not a priority, the F-35 can switch to beast mode, attaching external weapons for maximum firepower. The three faces of the Lightning II. One of the most brilliant aspects of the F-35 program is its modular design, which allows for multiple versions built on the same platform. The F-35A is the conventional variant designed for the US Air Force. The F-35B, used by the Marine Corps, features short takeoff and vertical landing capabilities, allowing it to operate from smaller ships and runways. The F-35C, designed for the Navy, has larger wings and reinforced landing gear for aircraft carrier operations. This shared design dramatically reduces maintenance and training costs while allowing allied forces to cooperate seamlessly in joint missions. Pilots and preparation, the human edge. The pilots who fly the F-35 are as vital as the machine itself. At air bases like Hill Air Force Base, they prepare in specialized facilities resembling athlete locker rooms, where they suit up in G-suits that counteract the forces of high-speed maneuvers. Their survival vests contain essential gear such as GPS systems, flares, and first aid kits, ensuring readiness for any emergency. Every mission begins with meticulous preparation, where pilots rely on their helmet systems to connect directly to the jet's sensors and data streams, effectively merging man and machine into one synchronized entity. And that wraps up our deep dive into the incredible F-35A Lightning II, the jet that's redefining air dominance for the modern age. If you enjoyed this video and learned something new, don't forget to give it a thumbs up and make sure to subscribe.